Now we are going to see the relationship between refractive index, real and apparent depth. Now let us understand the figure first. We have an object. Let us take it as maybe water or maybe inside a glass block. Let us take it as glass block. Okay. कि glass block उसके ऊपर रखा है या water भी ले लीजिए. The only thing is it should be a denser medium. Okay. So the light ray, there are two light rays going out. Two तो हम लेते हैं for the figure to be made. There are many light rays. So two we consider for any figure or any image to be made. Minimum two light rays are required. So one light ray is going like this. The first one going normal moves out in a straight line without deviating. जो भी normal जाती है वो deviate नहीं करती है. Okay. The one which is at an angle, when it is going from denser to rarer, this is the normal. It moves away from the normal. And when it is moving away, we are drawing a straight line which is intersecting the normal at I. ठीक है. So they are meeting at I and I पे उसका image form हो रहा है. किसका? O का. Right. So what happens is we are taking इसमें this is angle of incidence. भाई ये incident ray, ये normal. This is the angle of incidence. This is the angle of refraction. Now you need to understand 2-3 things. अरे कहाँ गया? हाँ. So when this is R, that is CBM is R. Okay. So this entire thing, ये जो सीधा ऐसे आ रही है और ये, this is also going to be R. Vertically opposite angles हैं. Okay. So this, both the twos are R. Now one thing more here is that this is and this is perpendicular क्योंकि दोनों normal है. Okay. And this is acting as a transversal. Okay. So if this is I, this is also going to be I. Alternate angles हो गए, parallel lines के alternate angle. ठीक है. अब एक चीज और है आपकी, the same thing if this entire thing is R, ये दोनों again normal है, this is acting as a transversal, so this will also be R. I hope this is clear. If not, please go through the video again. If you want, once again I can speak, but you can go through the video. The only thing I'm saying is ये गई आपकी incident ray, ये आई refracted rays. This is angle of refraction, this is angle of incidence, right? The entire thing is equal to this क्योंकि ये straight line ये आ रही है और ये आ रही है. So if this is R, this is R. Again, because these two are normal, means 90 degree. 90 degree, both are 90 degree means they both are parallel to each other. So this is acting as a transversal. ये I, तो ये भी I. And in this is acting as a transversal. तो ये पूरा angle R है क्योंकि ये दोनों vertically opposite है. So this will also be R. Okay. So now we need to find out the relationship. According to Snell's law, according to the Snell's law, my pen is not working. Right. So refractive index of air with respect to glass. क्यों? क्योंकि ये यहां से यहां जा रही है. This is air, this is glass. Will be equal to sin. Now sin I. Sin I ये है. कौन सा एंगल? OBN. Sin OBN. Please listen very carefully. Will be upon sin R. Snell's law होता है sin I upon sin R is the refractive index. So we need the refractive index of air with respect to glass. Okay. So the incident angle is this and the refracted angle is CBM. हो गया. Now from the figure what we see is that angle OBN. ठीक है. कहाँ गया? OBN. This will be equal to what? BOA. हम आपको पहले बता चुके हैं BOA because they are alternate angles. ठीक है. ये दोनों आपकी parallel lines हो गई. Similarly, angle IBN, that is CBM, ये वाला जो angle of refraction था, will be equal to क्या angle? IBN. ये पूरा का पूरा क्योंकि it is vertical opposite. IBN. This is vertically opposite angles. Or which will also be equal to, now IBM is equal to BIA or BID जो आपको लेना हो, BIA. क्यों? क्योंकि again ये alternate angles हैं. ठीक है, which means here that mu AG can be written as sin angle OBA की जगह हम क्या लिख सकते हैं आपका एंगल BOA, इसकी जगह हम ये लिख सकते हैं साइन ऑफ एंगल दिस, एंड साइन ऑफ CBM की जगह हम क्या लिख सकते हैं आपका BIA, एंगल BIA. So from 1 and इस पूरे को ले लीजिए आप टू, आपने रिलेशनशिप ढूंढा है, you can write this. Okay, now we will find the values. Sin BOA will be equal to sin BOA क्या हो गया BOA इस ट्राइंगल में, you say triangle BOA में, in triangle BOA, I hope you can see, right, in triangle BOA, sin BOA will be what? Perpendicular upon hypotenuse. ठीक है, so the perpendicular is AB and the hypotenuse is BO. Okay, similarly in triangle BIA इस triangle में again sin of angle BIA is equal to again perpendicular upon BI, that is the hypotenuse, right? So here if we put this in this equation, this is equation number 3. So from equation 3 we have mu AG is equal to AB upon BO divided by AB upon BI. ठीक है, and to get more space we don't need the figure now here, so I'm rubbing this out. You get mu AG is equal to AB upon BO into BI upon AB. This gets cancelled out, which have BI upon BO. Now please see the figure. You have the figure with you. What is there that this we were having the figure like this, ऐसे करके जा रहा था. This was B point, this was A point. Practically ये तो हमने microscopically दिखाया था, जो फैला के दिखाया था. Practically the point B is very very close to A, and this was the thing, this was O, this was I. Okay, when B is very close to A, then BI can be said to be AI. ये point इसी के पास है, तो BI जो होगा वही AI होगा, and BO जो होगा वही आपका AO हो जाएगा. Okay, because A and B point are very close, so you can write it as a line here, as a point here, as B is very close to A. BI is equal to AI and BO is equal to AO. So the refractive index of A with respect to G will be equal to AI upon AO. Now what is AI? Please see the figure. AI was your AI was your apparent depth, ठीक है, and AO was your real depth, right? In other words, अब आपको refractive index of glass with respect to air चाहिए, तो ये हो गया आपका real depth upon apparent depth. Both the ways you can write it. So this is the relation between apparent depth, real depth, and the refractive index of the given medium. Now related to this only, we have apparent bending of stick in water. You must have seen that the stick, it bend whenever you put it in water. A pencil or a scale, when you put in a glass container which is having water, you see that the stick has been bent. Apparently it seems to be bent. The reason again is the same. I want you to go through that example in your books. If there's any confusion with the figure or with any explanation, please do put up your queries. Not today, but the next day.